All right, let's work on DSMA Part 2. A critical part of succeeding in statistics is reading the problem and grabbing what you need out of the problem. And sometimes it gets a little tricky. So we're going to work on that of where we circle words in a problem and we figure out what we need. So we're just going to do a little practice with translating sentences or phrases. So this one is 5 tickets or more. Okay, so that means we can include 5 tickets. Now we're not going to have part of a ticket. So that means we're going to jump to the next one, which would be 6 tickets, 7 tickets, 8 tickets, and so on. Then we use these 3 dots to denote that it's going to go on and on because they didn't tell us a maximum number of tickets. All right, so we started at 5 and it said or more. So we grabbed any numbers that were greater than 5. B wouldn't work because it has fractions. Fractions are not going to make sense for tickets. C and D are not going to work because those are less than, well, they're 5 or less. So those are not going to work. So it's going to be A. All right, this one is fewer than 4 dogs. Fewer than 4 dogs. Okay, so we can't have 4 dogs. We can have 3 dogs because that's fewer than 4. We can have 2 dogs. We can have 1 dog. And we have to be careful here. We actually could have no dogs, right? There are people who have no dogs. I don't understand that because I have 4 dogs. But it does happen. Therefore, the answer is B. A isn't going to work because that's negative numbers. C would be 4 or more. And then D looks like it would work, but it doesn't include the 0 dogs. All right, again, we're translating. It says more than 20 chairs in a room. There are 25 chairs in the room. So that there are a total, that could be worded a little better. There are a total of 25 chairs in the room. So it says more than 20. That means we're not going to include 20. We would start with 21, 22. You can't have part of a chair. 23, 24, and then 25 is going to be the largest number because there are no more chairs than the 25. Looks like B again. Okay, C at first looks like it would work, but it has 20 and it says more than 20. So that's where we have to be really careful. All right, let's look at some inequalities. It says the number of ducks in a pond, D, so my variable is D, is between 13 and 18. So we have to watch on these problems. If they want us to include 13 and 18, they are literally going to tell us. They're going to say that it's inclusive. Because it does not have that wording, we are not going to include 13 and 18. So that means that I have to use a less than sign. I do not want or equal to, because I do not want the number to be equal to 13. I don't want it to be equal to 18. So we're going to use a less than sign on either end. This is one of those compound inequalities or double inequalities that we've been looking at. And again, because we don't have the word inclusive, we are not going to use less than or equal to. We're only going to use less than. All right, this problem says the measurement of the particle m, so we know we're going to use the variable m, is exactly 4 millimeters. Right? It doesn't say less than, doesn't say greater than, so we are going to use an equal sign and say that m is equal to 4. So remember, a variable is just a placeholder. We can name it anything that we want. And you're getting practice here of having variables have different letters. All right, the number of broken glasses in a shipment G, our variable is G, is not 3. It doesn't say less than, doesn't say greater than, it says is not. So we're going to use an equal sign with a slash through it to denote that G is not equal to 3. The ages of the competitor C is between 20 and 71 inclusive. That's that word I was talking about. So because we see that word inclusive, we know that we can use a less than or equal to. C is going to be in the middle. We always start with the smallest number first. So 20 is less than or equal to C because of the inclusive. So C can equal 20, and then is less than or equal to 71. C can also equal 71 because of that word inclusive. So we want every number between 20 and 71, including 20 and 71. The average weekly grocery bill, G, is between $150 and $190. There's no inclusive, so we cannot include those endpoints. Therefore, we're going to start with the smallest number. We have 150 is less than G is less than 190. Right? Because we don't have inclusive, we're going to do a less than sign. G is going to equal all the dollar amounts between 150 and 190, but not including 150 and 190. The proportion of cans in a shipment that are damaged, P, so my variable's P, is at most 0.28. So at most is the one I have to think about. We have 0.28. At most means that that's the largest number I can have, right? I can have all the numbers less than that, but I cannot have any numbers larger than 0.28. I'm going to use a less than or equal to, and then make sure my variable is correct with the P.